Hello everyone, welcome to the class. Just give me one moment. I'll just check if I'm online. Okay, welcome back to the class. And in today's class, actually we are going to see not just the introduction to electric dipoles, but we would actually looking into the numericals from the first, right? Basically, we would basically be covering from the electric charges that we studied, the concept from electric charges to dipoles. Whatever we studied, we'll try to look into numericals into each of them. I've done a numerical video earlier also. I'm doing this is my second video that I'm doing, right? So it's second video for numericals. So this class is completely going to be based on numericals, but if you have any doubts, you can ask me in the chat box. I'll be there to answer the same. And before we begin, my name is Mohana. I'm a physics educator at Unacademy, and I'll basically be taking your class 11 and 12 physics. Okay, I've shared my community link. This is my Telegram channel. So any updates regarding any of the courses, it will be shared in the Telegram channel. Okay, so you can join the Telegram channel. At the same time, this is the Unacademy ICSE and ISC board common Telegram channel. So you can join this Telegram channel as well. Okay, so from here, let's how we have special classes free classes on the YouTube platform. We also have a number of free classes on the Unacademy platform as well. So these classes you can take from any of your favorite educators. These are absolutely free. So on the platform, the classes that we take, we have named them as special classes. So we have an interesting pool feature, so you can engage with your educator during these special classes through this pool, and you can get, since these classes are live classes, you can get all of your doubts cleared as well. Now, the link to the upcoming special class for class 12, I'll share in the coming week. All right. And if you're interested, okay, in taking a plus subscription, then you will get a number of benefits. That is, one is, first of all, you can learn from the comfort of your home. Right, you can choose the timing in which you're taking the class. In case if you cannot attend for the class timing, class recordings will be there. You can watch them as well. No, you have unlimited access to all courses, right? Physics, chemistry, math, and biology, you'll have unlimited access to all of these courses, and all the educators on the platforms are good, so you'll be learning from top educators. And in case, let's say you couldn't attend the class live today, and you're watching the class recordings and you have some doubts, okay, regarding the topics you've learned. So for that, we have come up with a doubt clearing session. So this happens if you take any course. If a course is starting today, every fourth session in the course is basically a doubt clearing session. Okay, so what we do in this doubt clearing session is, any doubts, okay, any doubts concept wise you have, you can get them cleared on that class. So 3 days you're actually learning new concept. 4th day is basically for doubt clearing session. All right, and in special classes we will cover your entire syllabus, and every weekend we also have live test series. So in case if you are, I basically believe if you're learning if you're learning any concept, if you're taking a test, you'll know how well you've learned the concept or not, right? You've understood the topics from the concept or not. So you can always take the live test series. You can attempt it. Right after the live test series, there will be a analysis session. Okay, so basically we will be discussing about the questions that you have attempted in the live test. In case you've got all the questions right, then you can actually check in. You can ask the educators if there are any better ways or easy ways to solve. You can learn that also. We are coming up with new batches for the month of June, so stay tuned to that. And if you look at the pricing, usually the price wise, for the longer duration you take, the course price per month it reduces. Okay, so if you're taking a 12-month course, right? So if you're taking for 1 year rather than taking for 3 months, if you're taking for 1 year, because you're just going into starting the new academic year, the course price is just per month is 1,438. Right now, in case if you're using my educator code MTIS10, you will basically be getting a 10% off on any subscription that you're taking. Okay, all of these you'll get for 10% subscription, 10% discount you will be getting for the same. All right. Now, the Unacademy is also has the Unacademy National Scholarship Admission Test. If you're going to attempt your IIT JEE NEET UG in the coming 2023 academic year, and if you're in class 9 or 10 and you're looking forward for foundational courses, then this test would be apt for you. So this is a computer-based offline test which happens in the which is happening in the Unacademy's offline centers, right? So the test last date for registering is on 2nd, and the test will be conducted on 4th and 5th. Now, depending on what is the percentage you're getting, if you're coming in the top 40 ranks, you can win an iPhone. All test takers can also get an Unacademy t-shirt, but at the same time, for the top rankers who are coming in, you can get up to 90% scholarship depending on how much percentage you've got. Okay, so this this is up to 90% scholarship. Okay, this in case if you're taking these courses, okay, for the next 1 year, if 1 year or 2 years, if you're taking these courses from Unacademy centers, offline centers, or if you're taking online subscriptions, right, like the plus course subscriptions, if you're taking both of which these 90% scholarship applied. Now the test has a for the test takers, you need to pay a 199 rupees to take this course, to take the test. Okay, that's the registration cost. Actually, you can use my code MTIS10 to avail a 10% discount. And there is also a number of special classes, the free classes I spoke about earlier. There is a number of free classes in the Unacademy platform that I had recorded for the the live classes that were taken for the month of April onwards. So for that, again, to access this, you can click on the description box. There is a link. Okay, just click on that link. It will take you class 12 link. It will take you towards my page. You can just go and watch all of these courses. Okay, or again, you can use my code there also, MTIS10. If you're using the code, if you're going through the platform, it will again take you to my page where you can look at all the courses. Okay, and with that note, let's begin today's class. So when we first learned about electric charges, the first concept, right, the first basic concept we learned was about quantization of charge, right? So in quantization of charge, basic concept we learned. Okay, just give me 1 minute, 1 moment, please. I'll just get back. I'm sorry about that. Okay. The first concept, the first question, this is a numerical based class. The first question we are learning is solving as a polythene. So all of these questions I'm solving today is taken from your reference books, right? Your Newton. Right, I'm basically taken these questions. Most of the question I've taken is from Newton ISC Physics, right? This is where I've taken my questions from, and also some of the books I've taken from your reference book, that is the New Simplified Physics by S.L. Arora. All of these are taken from your reference books for ISC Physics. All right. Now, a polythene paste rubbed with wool is found to have a negative charge of 3 into 10 to the power of minus 7 Coulomb. Now, using that, we have to estimate the number of electrons transferred from which to which. And is there a transfer of mass from wool to polythene? Okay. The first question asked. To solve this question, the concept you will be using is basically quantization of charge. So the total charge in any system, okay, the total charge in the polythene bag or the wool, right? The total charge in any system is basically equal to the number of electrons, that is the integral value that you're seeing, into the charge of the elementary particle, the number of elementary particles, or the charges, the number of charges plus the charge on one single particle. Okay. There's a charge of one single, what in a given system, right? Let's say, okay, let's say there are n number of positive charges. Okay, now what is the charge that is of on one particular positive charge, right? That is the charge value, that is E times how many charges are there, that is n number of charges. That gives you the n number of charges. That basically gives you the total charge of the system. Okay. So this is basically the principle behind you. This is actually using this question is based on quantization of charge. It's an important question. right? So quantization of charge Q is equal to N into E, right? So here what they are saying, the polythene piece rubbed with wool was found to have a negative charge. Okay, so negative charge of 3 into 10 to the power of minus 7 coulombs. So charge over here is given as 3 into 10 to the power of minus 7 coulombs. Okay, when the polythene piece is rubbed with wool, right? When the polythene piece is rubbed with wool, it's found to have negative charge. Estimate the number of electrons, right? Negative charges are what? These are basically electrons. Negative charges in this case are basically, the negative charges in this case we are talking about are electrons. Okay, and we have to calculate estimate the number of electron charges. Okay, from the question they are asking, the electrons that are transferred is from which to which? Is it transferred from polythene bag to wool, or is it transferred from wool to polythene bag? That's the question that is asked for us. So if you look at this question, if you look at this, when the polythene piece is rubbed with wool, okay, you have a polythene piece. You have a polythene piece. If this is basically rubbed with, some woolen cloth, okay. And what are they saying? The polythene piece is found to be, piece is found to have some negative charges, right? So what is happening? How is the electron transfer happening? The electrons are always, right, whichever of the two objects here, one is the of the two objects here, that is a polythene piece and a wool, which has a lower work function, that will give out its electrons, right? Wool over here has had a low work function. That's why when it was rubbed on the polythene piece, right, the electrons from the wool has gone towards the polythene piece. So the polythene piece has has a total negative charge, and this wool has lost some electrons, right? So there's a deficit of charge in the wool, right? There's a deficit of negative charges in the wool. So this has become a positive charge. Now over here, the question is negative charges. Hence over here in this case, we can say electrons are transferred from wool to polythene, right? In this case, we can say, to answer the question number 1, we can say electrons are transferred from wool to polythene. Okay, so that answers the first question. Estimate the number of electrons transferred from which to which. From which to which? Basically electrons. In this case, polythene bags acquires an electron, right? So the electrons from wool has gone to polythene bag. Now we have to find how many electrons are gone. So the question is asking us to find n. We know the total charge, right? We know the total charge, and we know the what is the total charge we know. So, but we know what is the charge of an electron, right? Charge of a positive charge, right? Charge of an positive, in this case, E is basically equal to 1.6 into 10 to the power of minus 19 coulombs, because that's the charge of one electron. Charge of an electron and proton are same, the magnitude is same. If it's an electron, we add a negative sign just to indicate that it's an electron and whether it's a positive or a negative charge. That's it. Okay. So here, if you look at this, if you look at this, we have to find n. Basically, what we need here is the number of electrons transferred. What is the number of electrons transferred? Okay. So that number of electrons transferred, that is, we can get that from this equation. N is equal to Q by E. What is Q? 3 into 10 to the power of minus 7 coulombs by, what is this electron E over here is basically, the charge over here is charge on one electron is 10 to the power of minus 19 coulomb. So from here, if you cancel, coulombs gets cancelled, 3 by 1.6, right? That is around 1.875 into 10 to the power of, this goes on top, minus 7, so plus 12, right? So many number of electrons, right? So many number of electrons has been transferred from wool to polythene. Okay, these are the number of electrons that are transferred sorry about this. Okay, these are the number of electrons that are transferred from wool to polythene. Okay, polythene. Okay, now second part of the question asks us, is there a transfer of mass from wool to polythene? Okay, when electron has a little bit of mass, right, they have a very small mass at least, right? So when electrons are transferred from wool to polythene, so polythene bags acquires a small transfer of mass is happening from wool to polythene. So polythene, actually that piece of polythene acquires a little bit of charge. Okay, so it's sorry, not charge, the mass of the polythene bag increases by a very small amount. Okay, so what will be the transferred mass in this case? The second page, what will be the transfer? The second question, right? We'll check out what is the transferred mass, right? The transferred mass, right? The transferred mass. How much mass is transferred from wool to polythene, right? This transferred mass is equal to what? What is how many number of electrons? That depends on how many number of electrons got transferred from basically your wool to the polythene bag, right? That is one part, right? Another one is what is the mass of one electron. Okay, another quantity that it depends on is what is the mass of one electron. Okay, we know this mass, right? M, in this case mass M is equal to 1.875 into 10 to the power of 12. Those are the number of electrons that are transferred from wool to polythene, right? Into what is the mass? Into what is the mass of one electron? Mass of one electron will actually be the mass of one electron will actually be 9.1 into 10 to the power of minus 31 kg, right? That's the mass of one electron. From here, if you're finding the total mass will be 1.71 into 10 to the power of minus 18 kilogram. Okay, so this is the answer for the second part of the question. Okay, so one question we did is based on quantization of charge. Now let's move on to the next topic. Now then we learned about Coulomb's force. Now Coulomb's force basically gives us the Coulomb's force basically tells us about the force, electrostatic force acting between two particles, right? Between two charges, sorry, the electrostatic force acting between two charges when they are separated by a small distance, okay? And it also depends on the nature. The force actually acting also depends on the nature of the medium it's placed in. So this electrostatic force is basically proportional to the product of the charges by the square of the distance between them. So you can introduce, to remove the proportionality constant, you can introduce this constant k, which is q1 q2 divided by r square, and now this k is nothing but 1 by 4 pi epsilon naught, which is basically 9 into 10 to the power of 9. This is the magnitude that we want. Okay, then this will be Newton meter square c inverse 1. This will be Newton meter square c inverse 2. Okay, that's the unit. So from here, if you see, F is basically equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square, and and F is basically given in terms of Newton, right? It's a vector quantity because we're talking about a force. So if you take any two charges separated by a small distance, so the force acting on the two charges is given by the Coulomb's law. Okay, now let's do one question based on the same. So the question we are seeing here is the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Okay. Now knowing this, you have to find what is the distance between the two spheres and what is the force on the second sphere because of the first sphere. Okay. So here we have a small sphere. This is basically 0.4 microcoulomb. Okay, and we have another charge over here, right? This is a positive charge, and we also have a negative charge. So this is around minus 0.8 microcoulomb, and the entire system, they are kept in here. Hello, Suhas, hello. Right, and they are separated by a distance. Now if you look at their distance of separation, they are separated by a distance of what? That is not given over here, right? That is what we have to find. We have to find what is this r. Okay, but we know the force on the small sphere, okay, of 0.4 microcoulomb Okay, here because it's minus 0.8 microcoulomb doesn't mean it has a lower charge. Okay, because it's a negative number. No, here the sign over here indicates that it's a negative charge, and the positive sign over here indicates it's a positive charge. So if you look at the magnitude of the negative charge is more, which means this charge size is small, this charge basically is more, right? The electrostatic force on the small charge due to this charge over here, positive charge over here, is already given. Okay, 0.9. Now what will be the direction of the force in this case? Because one is a positive charge, another is a negative charge. This charge will experience a force towards us in this direction. This force it is experiencing is actually given as 0.2 Newton. Okay, right. So this charge is an attractive charge. It is already given in the question as well. Okay, now what is the distance between the two spheres? That's the first part of the question. Alright, let's do the first part of the question. For that we need to know Coulomb's force, right? Coulomb's force is given by 1 by 4 pi epsilon naught Q1 Q2 divided by R square. We know F, we know what is the value of 1 by 4 pi epsilon naught. Q1 Q2 is also given, so we have to just find R. So this equation we can write as R square is equal to 1 by 4 pi epsilon naught, right? Q1 Q2 divided by F. What is this value? This is actually 9 into 10 to the power of 9, right? Into what are the two charges? One charge is basically 0.4. What is this value of micro? Micro value is basically 10 to the power of minus 6 coulombs into the next charge is 0.8, right? I'm just not writing the negative sign simply because that's just a negative charge. That's just to indicate it's a negative charge. Okay, into 10 to the power of minus 6. Okay. All of this divided by what is the force acting on them? 0.2. So if you find the value for this, you will get, okay, 2, this becomes 0.1 times 0.2, 0.2 times 0.8 is around 1.6 times 9. This will be somewhere around 144 into power terms minus 6, right? This is basically square. It's not square, sorry, this is a force, so not square. I made a mistake. No, this is just in terms of newtons, right? So minus 6 is basically 12, and then from this you can write as 2 into 10 to the power of minus 1. That will also come on top. This becomes 10, right? Into all of this is basically, if you solve for this, you will get around minus 4. But what is the unit over here, right? From here you can see the unit R will become in meter square. Okay, now if you take the square root of this will become 12. 144 is basically 12 square gives us 144, right? Square root of 144 is 12 into 10 to the power of minus 2. This will be in terms of meters. Okay, this will basically give you a charge in terms of meters. Okay, so if you substitute, how are we getting meters here? If you substitute the value of the units of coulombs, right? The unit over here in case will be in 9 into 10 to the power of 9 will be Newton, meter square, Coulomb inverse 2, and this one has a charge of coulombs, and this one again has a charge of coulombs, so this cancels by force is given in Newton. So all of these cancels, and what you will only have is meter square. Now, when you take the square root of this entire thing, this is R square. Then when you take the square root of this entire equation, you will basically get this value. This, if you want to write in centimeters, it will be around 20 centimeters. So these two charges, that is 0.4 microcoulomb and minus 0.8 microcoulomb, when separated by a distance of 12 centimeters, this charge over here, this particular charge over here, because of the force of attraction from this charge, so negative charge, no, this experiences a force of 0.4 Newton in this direction. We have solved the question number A. What is question number B? Right? What is the force on the second sphere? Because due to the first one. Okay, what is the sphere? The force of the second sphere due to the first one. So that will be in this direction, right? The force on the second sphere due to this one, right? So that charge, because this is a negative charge, it's a positive charge, right? So this negative charge will feel an attraction in this direction because of this positive charge. Okay, let me take it as Q and let me take it as minus Q. This is force because of the positive charge. Now this force will be because of the negative charge experience in this direction. What will be the magnitude of the force? Here, same equation, right? If I want to calculate what is the force on this one due to this one, we'll just use the same equation, 1 by 4 pi epsilon naught Q1 Q2 divided by R square. You will again get the same value. The force acting on it is 0.2 Newton. Because of this charge, right, the force acting on them. So B, the force acting on them will be same, right? Again, the force acting on the second charge will again be 0.2 Newton. So because of this charge, this one experience a force in this direction. Because of this charge, this one experience a force in this particular direction. So these two forces will actually be opposite to, will be an attractive force, and they'll attract each other, and the forces acting on them on both charges will be same. Okay, so that's the first thing. So that's what we learned about in forces, right? About in forces, this is what we've come across. Now let's try to do one equation based on one question based on the electric field lines, right? Now what is an electric field, right? Electric field is given by a very simple equation. Right. So electric field is at a point is defined as the electrostatic force per unit test charge, right? If you want to study about the electric field is given by 1 by 4 pi epsilon naught Q divided by R square. So the electric field is basically nothing but force per unit charge, test charge actually. Force per charge also gives you the force per test charge, right? Force per charge also gives you the test charge that you're introducing, right? Force per charge also gives you the electric field. An electric field is basically a vector quantity. Force per charge, so its unit is Newton. Charge is -1. Okay, that's the equation, right? And it's a vector quantity. All right. Let's try to do one question based on electric fields, right? Okay. Right. So instead of substituting for this, let's try to do one question. Let's say it's like that. Okay, let's do this. Right. Let's say we have a charge. Let me try to do that. Okay. Let's say there are four charges. Okay. Let's say there's a circle. Okay. And on the circle, let's say at the four ends, right? At the four ends, there are 4 charges. Not too great. All right, let me just draw this once again. Okay, now let's say there is one charge over here. Okay, and at the 4 corners, right? Let's say on the circumference of the circle, let's say there are 4 charges. Okay, so one charge that is over here, let's say it has a charge Q. Let's say this one has a let's say this one has a charge Q. This charge, let's say it's B. Let's say this has a charge 2Q. This one has a charge, this is C. Let's say this has the biggest charge, 4Q. Till now we took only positive charges, right? All of these are basically positive charges, and at this point, let's say the charge over here is 2Q. Okay, so these 4 charges are placed on the circumference of the circle. Okay, such that if I draw a line joining these two, right, A and C and B and D, so these are actually staying on that line. Okay, the charges are such that A and D and perpendicular to each other, and A and C is also perpendicular. They're perpendicular to each other. Okay. Now we want to write a formula for the electric field on each of these charges. Okay, first of all we want to write the formula for that, and then now what we're going to do is we want to know what is the charge, what is the field at the center of this circle. At the center of the circle we want to know what is this field. Let's mark that as O. At this point we want to know what is the field. Okay, and also to do that, what will we do? We take a test charge. Okay, these being your source charges, we will introduce a test charge over there, and we will see what is the force experienced by this test charge because of all of these charges over here. Right. We want to find out what will be the magnitude and direction of the field lines that is acting on these charges due to all of these charges. Okay, that's what we are trying to do in this equation. Just give me 1 minute. Alright, okay. So just to do this, let me draw another circle, a bigger circle, and we can do 1 point at a time, okay? We want to find out what is the charge. If I introduce a test charge over here, what is the value of the test charge because of this charge over here, right? Okay. Now, before going ahead, we need to know what is the distance, right? What we need to know, what will be the distance of this radius. Let's say the radius of the circle, right? This radius of the circle is basically r. Everywhere around the radius of the circle, let's take that as r. Now, what will be the effect of the charge A? The charge A is over here, right? The charge A on the at this point in the center. What will be the field line like? This is a positive charge. This is Q. The test charges, unless otherwise specified, what is introduced is always a positive charge. So because of this charge, the force experienced on this charge, because of this positive charge, the force that this charge, the test charge we introduced at the point where we want to study about the electric field line, that will be in the that will be repulsive force. So this charge will repel this force. This charge, because of this charge, this particular charge, test charge over here, will experience a repulsive force, and the electric field lines, if you look at it, will be in the direction of the force that is acting, so it will go in this direction, right? So the electric field lines then will be in this direction. This is for A. If I want to write the magnitude for the same, what will that be? Very simple. It will be 1 by 4 pi epsilon naught, right? What is the charge over here? Q. Q divided by, what is this distance you've taken? We have taken the distance as r, right? So r square. Okay, this field is acting away from A, right? This field is this basically force is in this direction. Electric field lines is also will go in the same direction, right? So this will be in this direction, right? This is along this A. Now, because of this charge B over here, right? And the charge over here is 2Q, double the amount of charges in than A, right? Because of this charge over here, this charge will experience a force. This is a positive charge, again a positive charge. This one will push it down. It will push it down, force, and again your field will be in the same direction, right? This will go down. So this is basically the field because of the charge B. Okay, so in this case, the force because of the charge B is given by 1 by 4 pi epsilon naught. What is the charge here? 2Q, right? Again, when you're writing the vectors, you draw larger vector to say the force acting, the electric field at that point is much more than because of the field of A, right? TQ divided by r square. Now again, this will be again away from B. This is not towards B, it's away from B. It basically talks about a repulsive force. Now, because of this, similarly, there is a charge D down here, right? This also has 2Q. That is the charge over here. This is also 2Q. Because of this charge, on this positive charge, there will be a repulsive force in this direction, right? This will be the field because of D, right? Electric field in this place because of this charge will be in this direction. But what can you say about this field D over here? Now this is again 1 by 4 pi epsilon naught, okay? 2Q charge over there by r square. But this is again away from D, right? This is away from B, this is away from D, right? In this case, you have the electric field intensity in these 2 points are actually the same, but they are acting in opposite direction. So they cancel each other out. Okay, E and D are equal and opposite, and they cancel each other out. So E and electric field of E and D are equal, okay, but and opposite. They are equal but acting in opposite direction. Hence they cancel each other. Okay, hence they can we can say hence they cancel each other out, or we can say being equal and opposite, they cancel each other. Okay, cancel each other. Now what about the other charge? Right, there's one more charge that is there, right? That one more charge is basically your charge C that is placed over here, right? This one has the highest magnitude, it has 4Q. Charges over here is large. Because of this charge, the electric field lines in this place will be, this is again a repulsive, right? The forces between them are repulsive. Electric field lines will be in the direction of the force. So again, the electric field line will be in this direction. This is because of C, and this one is largest than compared to other thing because this has 4q amount of charge. So if you're writing the field line for C, it will be 1 by 4 pi epsilon naught. This is basically 4q divided by r square. Okay. Now, and in all of these places, right? In all of these, now if I have to write an equation, right? The resultant field at O. Okay, the resultant field at O. What will be the field? The resultant field E at this point E, O, right? We know B and D, they are acting in opposite directions, so they cancel out each other. But A and E, though they act on opposite direction, their magnitudes are not the same. In this case, they are equal and opposite in acting in different directions, so they cancel out, but they are acting in different directions, but their magnitude is same. So from here, the total resultant field will be because of the field, the electric field because of the point charge C, and electric field because of the charge E. These two charges, electric field will not get contributed. So this is, in this place you will have electric field because of the charge C and electric field because of the charge E. These two will be there. So the total electric field will be what? EC in this case is basically 1 by 4 pi epsilon naught, right? 4q divided by r square. Now, what is the direction between them? They are acting in opposite direction. Okay, so minus, right? Minus, the direction is opposite. So because of that, right, 1 by 4 pi epsilon naught, then this will be q divided by r square. Why the negative sign? Only reason the negative sign over here exists is because they are acting in the opposite direction. Okay, so I can write this entire equation in just one simple form, right? I can just write this as 1 by 4 pi epsilon naught 4q minus q. At this point it will be 4q minus q divided by r square. Okay, now this will be 1 by 4 pi epsilon naught 3q divided by r square. Now let's do this one. Let's substitute some value over here. Let's say for this given equation, for this given system, the charge is q, right, has a value of 0.4 microcoulomb, and r is to be taken as 2 meters. Okay, so the resultant electric field, okay, at O, right, at O is because of A, that is acting in this direction because of a charge A, that is q. This is basically 2q. This is basically 2 into 0.4 microcoulomb, right? And on this side we have 4q. So this is 4 into 0.4 microcoulomb. Okay, and this charge is repelling it much more than this charge, right? This is A and C. B and D, they are cancelling each other out. So the end resultant will be 1 by 4 pi epsilon naught. Sorry, this side it is not 4q, this is actually just q, right? So this charge is basically q, right? So here it will be, in this case it will be 3q, 4q minus q, right? 1, because they are in the opposite direction. So 4q minus q is 3q divided by r square. Q value, if we take the q value to be 0.4 microcoulombs, right? Then this one over here, 1 by 4 pi epsilon naught, we know the value is basically 9 into 10 to the power of 9, okay, into 3 into 3q is basically, q is what? Into 0.4, mu is basically 10 to the power of minus 6 coulombs, right? The whole of this divided by r square is what? 2 meters. This is 2 square. So if you solve for this 0.4 and 4, you can actually cancel this, and you will have 9 times 3 is basically 27, and this will be, this 4 I can write it as 4 into 10 to the power of minus 1, right? Minus 1 minus 6, this is 9 minus 6 is minus, right, this will be 10 to the power of 3, right? But if I want to write, in the point of decimals, then over here I can actually write this value as 2.7 into 10 to the power of 10 to the power of I'm sorry about this. Right, let me write here only. Okay, so the value, once we substitute it, we'll get E, the final value, to be around 2.7 into 10 to the power of 4 Newton Coulomb inverse 1. Why force is big? Because E is given by force per charge. Okay, now if this is the case, if you take Q to be 0.4 microcoulombs and R, the distance between them is 2 meters. Okay, but alright, in the same form over here, what will be the direction? What will be the final direction? Okay, what will be the resultant electric field direction? The resultant electric field direction will be will be towards A. Okay, the resultant electric field direction will always be towards A. Why? This will be the resultant electric field direction because the magnitude of this charge C, right, is more. So the resultant will actually, the charge C is again positive, the test charge is also positive, so it will repel. So the electric field will be towards the charge A. Okay, so this is a question based on your electric field lines. Okay, now let's try, we have 15 more minutes. If you have any doubts, you can ask me in the comment box. Right, if you have any doubts, you can ask me in the comment box, or else we'll continue doing the question. And let's do one more question then, based on our electric field lines. Okay, this time let's take two charges. Let's take basically two charges, and the two charges, one is let's say one charge, point charge over here, A. Let's say this charge is basically around 3 microcoulombs. Okay, let's say we have another charge that is B, right? We have another charge, and let's say this charge is again this, let's say the magnitude of this charge, let's say this is a negative charge. Okay, so let's mark that as well. This is a positive charge and this is a negative charge. So let's say this is my positive charge and this is my negative charge. Okay, so this charge is around -3 QD. Right, in this case, let's say the charges, right, the distance between the two charges, if I look at the distance between these two charges, right, now this distance, this entire distance, right, it is basically around 20. Let's say this is around 20 meters. Okay, around 20 centimeters. This entire distance is around 20 centimeters. Okay, and this entire system, let's say it's placed in vacuum. Okay, now knowing this, what will be my electric field E? What will be my electric field E? Let's say this midpoint over here is basically O. Okay, at the midpoint we want to know what is the electric field. Okay, now what will be the electric field in this midpoint? Let us mark that midpoint also. Because of the two charges, what will be the electric field lines at this midpoint over here? Okay, and also we want to find out what is the electric field lines at this midpoint here, and let's first find that. Okay, so to find that, at the point, what will be, so the electric field will be because of both the charges, right? What will be the electric field line at this point O because of the charge A? That is given by the formula 1 by 4 pi epsilon naught, right? QA divided by this distance, right? A to O, the distance from A to O. Let's make this distance from A to O as x1 and let's just make this distance as x2, or we can actually make them as r1 and r2 as well, right? The entire distance is r, then we can take this as r1. This distance is basically, let's take that as r1, and let's just take this distance as r2. Okay, now at this midpoint, this will be qa by r1, right? qa by r1 square. So we can substitute the formula, right? This is 10 to the power of 9. Okay, this will be 9 into 10 to the power of 9 into, what is qa? What is the charge over here? This is 3 into 10 to the power of minus 6 coulombs by, what is the distance? Now, the entire distance is 20 centimeters. So r1 will be what? We are taking the midpoint. So r1 will be 10 centimeters. r2 will be 10 centimeters, right? 10 centimeters in terms of meters, when you're writing, it will be 10 into 10 to the power of minus 2 the whole square. That will be 10 centimeters, right? Now, this charge, this magnitude of this charge is what? If you solve for this, 3 sevens are 27, right? 27, because this will be into 10 to the power of 1, right? 10 to the power of 1 square, this becomes minus 2. So, minus 4, right? If you solve for this, you would basically get around 10 square minus 4. This will be 10 square. When it comes up, it will be minus 2. And this is into 10 to the power of 9. And this entire thing will be around 10 to the power of 6. What is the unit for this will be Newton per Coulomb. That is the unit over here, right? Now, what will be the electric field? Which is the direction of the electric field in this case? The direction of the electric field will act. This is, in this case, it's a positive charge, right? And the negative charge. The force will attract each other. The electric field will be in the direction of the force, right? So in this point, I can say this will be an electric field will be in this direction. This is for EA, right? We can say the electric field will be in this direction. Now, for the electric field at E, if I want to find out what is be my electric field, right? The positive charges, because of the positive charge, the electric field will be in this direction. Because if you take any positive charges, the electric field lines will always be always pointed radially outwards. For negative charges, the electric field lines will be always pointed radially inwards. Okay, there's one point property about the electric lines of forces we would have learned, right? So in this case, the positive charge, so electric field lines will be pointed radially outwards in this case, right? Now, the field at B, what will be the field at B in this case? It will be 1 by 4 pi epsilon naught. Again, charge Q, this is because of P, into R2 square. So we know what is R2 square, right? This is 9 into 10 to the power of 9. Charge B is what? This is in this case 3 into, I'm not writing the negative sign simply because the negative signs indicate, it just indicates it's a, this is just a negative, the minus sign indicates it's a negative sign, it's an electron. And the positive sign indicates it's a positive charge, it's a proton. That's the only thing it indicates, right? 10 to the power of minus 6, similar case as earlier. And this will be the whole of this divided by r square, right? The whole of this divided by r square is what? 10 into 10 to the power of minus 2, the whole square, right? This is the distance, because this distance is 10 centimeters. From here, we can see what is the electric field lines in this space. This will also be 2 into, this is again, that will not be 2 into, this will be 2.7 actually. You're taking this. This will again be 2.7 into, you have 10 to the power of 9, then you have minus 6, and here you get 10 square. That becomes, when it comes up, it becomes plus 2. Then you will have, this will be plus 4 as well, right? You cancel them, you will get 10 to the power of, right, from here you will get 10 to the power of 7. So I'm taking a decimal point inside, right? So I'll get 10 to the power of 6 finally. So over here I'll get 10 to the power of 2.7 into 10 to the power of 6, that is Newton per Coulomb, right? That's the field acting at this point over here. Now, what will be the direction? At this point, what will be the direction? The force acting on them is an attractive force, that is true, right? The force acting on them is definitely an attractive force. Oh my god, alright, I'm sorry. Let me just take the screen back. Okay, the force acting on those two charges, right? This is QA, this is a positive charge, and this is QB. Positive charge QA. Let's just look at what is the force acting on them, okay? Charge QB. Now the force acting on them, this is the force. right? This is the force equation. Force on QA due to the charge B. Force on the charge B due to QA. This is an attractive force. But and if I want to take at the midpoint, right? At the midpoint, because of these two charges, if I want to find what is my electric field lines like, okay? For the positive charge, obviously the point field is pointed radially outwards, right? The electric field lines will be in this direction. If it's a positive charge, then you can say, then the positive charge basically belongs to the positive charges will always be towards the force acting on them, right? The force on the electric field lines will be equal in this case. What is the force? What is the electric field line like in the case of the negative charge? The electric field lines in case of the negative charge, okay, that will be basically that will again be for a positive charge. The electric field lines are pointed radially outwards, right? That's for a positive charge. So over here the field lines will go this direction. For a negative charge, the field lines will be pointed radially inwards, right? So in this case, what will be the field lines because of B? It will again be in this direction. Force will act in the opposite direction, but it's a negative charge, right? The negative charge, the field lines will always be pointed radially inwards. The electric field line, because of the negative charge at this point, will be radially inwards. So what will be the resultant electric field line at O? That resultant electric field lines will be because of both the charges, right? Both are acting in the same direction again. So this will be because of the electric field lines in A and because of the electric field lines in B, right? We saw that the electric field lines for both of them is what? Is basically electric field lines was 2 into 10 to the power of 6, right? That's what we got for the positive charge, right? As well as the negative charge also had the same value, 2.7 into 10 to the power of minus 6. So 2 into, so these two has the same value, right? From here, if you're calculating what is the resultant electric field line, it will be 5.4 into 10 to the power of 6 Newton per Coulomb. Okay, this is the electric field line. Okay, now what will be now let's try to do one more step. If I take a negative charge, let's say the negative charge is around 1.5 coulombs, right? If I take a 1.5 coulomb of negative charge, okay, and place it at this point in the center. Okay, now this, if I place another negative charge, okay, this charge that I'm keeping over here is basically around this charge I'm just giving as Q0, right? If I'm introducing a test charge at that point, and the test charge, okay, is basically 1.5. This point is 1.5 microcoulomb of test charge if I introduce. Okay, what is the force experienced on this test charge? This test charge is a positive, right? This test charge, so this charge will actually push this charge away in this direction, but because of the negative, the positive charge will push this in this direction, in this way. The negative charge will, what will happen? Because of the negative charge, the introduced charge is a positive charge. This also will attract it in this way, right? The force experienced by this positive charge will be in this direction. Okay, but how would we calculate the magnitude? The magnitude of the force. Now we already know the electric field line is basically given by force per charge, right? Electric field is basically given as force per charge. Force per charge, right? In this case Q0. But from here I can find out what is my force if I know what my electric field is. I can find out the force, right? From here I can find out what my force is. Okay. From here, let me do this over here. I can find out what my force is if I know what is my electric field times the charge, right? Now, because this charge goes here, we'll know what is the electric field per charge, okay? The charge test charge, I have given the name as Q0, okay? Force is charge times electric field. So from here, if I write my force, what is the charge over here? The charge introduced is 1.5 into 10 to the power of, let's say in this case not microcoulomb, let's say the charge introduced is 10 to the power of nanocoulomb. So that will be around 10 to the power of 9 coulombs, okay? That is the force into what is the electric field strength. Electric field strength we just saw at this point what is the electric field strength. It is 5.4 into 10 to the power of 6 Newton per Coulomb, right? Newton per Coulomb. That's the charge over here. So from here, what will be the force acting over here? The 1.5 into 5.4 is basically 8.10 into 10 to the power of minus 3. Okay, into 10 to the power of minus 3 newtons. right? That will be the charge in this particular place. That will be the force experienced by this test charge having a charge of 1.5 nanocoulombs. Okay, that's the Q naught that we introduced over here. Okay, or 10 to the power of minus 9 coulomb. That's the charge at that point for Q naught. Okay, so this is, now what will be the direction of the point? The direction will be from O to, the direction will be from the force experienced. I'm sorry, I made a mistake here. One mistake that I did was basically the charge introduced, right? The charge introduced, if in case I said it's a positive charge, if it's a positive charge, the direction is in this side. The same time, if I introduce in the same place, if I introduce a negative charge, if this Q naught is negative, then what will be the force? In which direction will the force act? Okay, so if the Q naught is negative, if I'm introducing a negative charge in this place, right, this is a positive charge, this is a negative charge, right? So this will attract it in this direction. This is a negative charge, the test charge introduced is also a negative charge. The force acting will be in this direction. The positive charge, it will go in this direction. If it's a negative charge, it will be the force experience will be in this direction. Alright, so with that we are coming towards the end of today's class. So if you have I'll be taking one more class for torque experienced by the dipole, okay, and also about electric potential. In the you can just check out the class in the list of classes, right? You can subscribe to the channel, so the upcoming classes will be made live to you. And at the same time, we are going to start, this is an upcoming batch. This batch is going to start from 1st June and the mode of delivery is going to be in English. So for physics, I'll be taking, so we'll be meeting every Monday, Wednesday, Friday between 5:15 to 6:15 p.m. For math, Jyoti ma'am will be taking, chemistry, Manisha ma'am will take, and biology, Lakshay sir will take. Now, this course focus is on your midterm coverage. So all the first 5 units from your term 1 syllabus will be covered. Okay, so you can to avail, if you can also use my code MTIS10, right, to avail a 10% discount if you're taking the plus subscription. Okay, and the Unacademy is having the Unacademy National Scholarship Admission Test as well. In case if you're taking your IIT JEE, NEET UG in the coming 2023 or after that, right, then you can actually apply for this. If you're taking those exams in 2023, right, then you can apply for this course over here, and you can apply for this test over here. So the test last date is register for the test is June 2nd. The test will be held on 4th and 5th. Depending on the percentage of scores that you're getting on the test, if you're coming in the top 40 ranks, you'll have a chance to win an iPhone. All test takers will also get a t-shirt. And in case if you're getting the top, if you're coming in the top scores, right, if you're getting the top 5%, 10%, then depending on the top ranks that you're getting, you will get a scholarship. There will be a scholarship for you up to 90%. All right. Now, if you're in class 9 and 10, and if you want to take a foundational course, even that you can do. Now, for the course enrolling for this one, this is a computer-based test, but in the offline centers. Now, for enrolling for the course, you have to pay around 199 rupees. You can use my code MTIS10 to get a 10% discount on this. And also, we are introducing the community feature. My community link is given over here, so you don't have to miss any of the updates from your favorite educators. At the same time, you can also share your feedback directly with your educators via tools. And my community link is there. If you go have a look at the community, there will be some question asked in MCQ formats. You can try answering the same as well. Okay. So box bounty is nothing but if in case you're seeing any inappropriate content in any of the videos, and if you are going to report about the same, then you can claim the prize. And also like and subscribe to the channel, and share like and share the class videos, and also subscribe to the channel in case, right, so that you can stay updated about the upcoming classes. We have many upcoming classes coming on in the following days as well, so stay tuned to the channel. All right, thank you guys. I'll see you in the next class.